Previously, we have solved quadratic equations or second-degree equations by factoring. However, as we discovered in one of the previous sections when we were factoring trinomials, not all trinomials are factorable. So we need another method of solving quadratic equations. Quadratic equation, again, is an equation in the form ax squared plus bx plus c is equal to 0. So we need another method for solving quadratic equations, particularly those that are not factorable. So we're going to discuss two different methods for solving quadratics, and they are completing the square and later the quadratic formula. Now, not only can completing the square be used to solve quadratics that are not factorable, it can also be used to solve those which are factorable as well. But in general, if they are factorable, it is easier to use the zero product method or solve them by factoring if they are factorable. So let's look at an example of how to solve a quadratic by completing the square. So we're going to start with a fairly simple one. X squared minus 5x plus 6 is equal to 0. Now here I've outlined the steps for solving a quadratic by completing the square. The coefficient of the quadratic term must be 1. And here the coefficient of the quadratic term is understood to be 1. If it's not equal to 1 and you're going to complete the square, then you got to divide each of these creatures by whatever the coefficient of the quadratic term is so that it becomes 1. So step 1 is already done for us because the coefficient of the quadratic term here is equal to 1. So now we're going to transpose the equation so that the constant term is on the other side. So in order to do that, I must subtract 6 from both sides. So the plus 6 and the minus 6 here do each other in, and that leaves you with a negative 6 here. So step 2 is to transpose the equation so that one term, the constant term, is on the other side. Now I'm going to take 1/2 the coefficient of the linear term. The linear term is minus 5. So 1/2 of minus 5 is minus 5/2. So I'm going to take 1/2 the coefficient of the linear term. So again, 1/2 of minus 5 is minus 5/2, and then I'm going to square that value. So minus 5/2 squared will be equal to, the way I square a fraction is I multiply it times itself, so that's 5/2 times 5/2, which would be 25/4. So I'm going to add 25/4 here to this side of the equation. But what I do to one side of the equation, I have to do to the other. So I must add 25/4 here too. So take 1/2 the coefficient of the linear term. 1/2 of minus 5 is minus 5/2. Then you square it. Minus 5/2 squared is 25/4. Now what happens is that the resulting creature on the left side is what we call a perfect square trinomial. And a perfect square trinomial factors into a binomial square. This perfect square trinomial factors into the square root of the quadratic term. Square root of x squared is x. The square root of the constant term, the square root of 25/4 is 5/2. And use the sign of the linear term. So this is a perfect square trinomial that factors into a binomial square. In other words, the quantity x minus 5/2 times the quantity x minus 5/2 would give you this creature here. And of course you could check that out if you wanted to check that using FOIL. Or remember, the square a binomial, I square the first term. So that would be x squared. I take twice the product of these two. The product of these two would be minus 5/2. Twice the product, the 2's would cancel and just give you minus 5x. and I square the last term, if I take minus 5/2 and square it, that's minus 5/2 times minus 5/2, which would be 25/4. Okay? You take twice the product of these two terms to get the linear term. And I think I said that was minus 5/2, so it's actually minus 5/2 x times 2, which gives you minus 5x. Now you add these two terms together, minus 6 would be the same as minus 24/4. Finding a common denominator. And that gives you x minus 5/2 quantity squared is equal to 1/4. So you take 1/2 the coefficient of the linear term squared, add it to both sides, which gives you this creature. And the reason that I'm completing the square is that it creates a perfect square trinomial. And a perfect square trinomial always factors into a binomial square, which is found by taking the square root of the quadratic term, square root of the constant term, and using the sign of the linear term. Now that I've factored the perfect square trinomial into a binomial square, I take the square root of the left side and plus or minus the square root of the right side. Here the square and the square root, they do each other in and just gives you what's under the radical, which is x minus 5/2. And here the square root of 1 is 1, square root of 2 is 2, so that's plus or minus 1/2. And then to solve for x, I add 5/2 to both sides, so x is equal to plus or minus 1/2 plus 5/2. So now remember, this is a quadratic equation. It's of degree 2. So I have two solutions. One solution would be x is equal to plus 1/2 plus 5/2, which is 6/2, which is 3. The other solution would be x is equal to minus 1/2 plus 5/2, which is equal to 4/2, which is 2. So the solutions here for this particular quadratic is x equal to 2 or x equal to 3. Now in this particular case, this trinomial is actually factorable. I could have actually factored this and got the same solutions. But again, the reason that we're looking at completing the square is not all trinomials are factorable. So in the next example, we'll look at one which is not factorable, and we'll have to use a different method other than factoring to find the solution. Not all trinomials are factorable, so we can't find the solution to this particular trinomial, 3x squared plus 5x plus 1 equal to 0, because this particular trinomial is not factorable. So we have to use a different method, and the method that we're illustrating here is completing the square. So I have the equation 3x squared minus 5x plus 1 is equal to 0. Again, I've outlined the process of completing the square. If you're going to complete the square, the coefficient of the quadratic term must be equal to 1. Here, the coefficient of my quadratic term is not equal to 1, so therefore, I've got to divide everybody through by 3. So that gives me x squared minus 5/3 x plus 1/3 is equal to 0. So this is step 1. Now I've got to transpose the constant term so that that's on the other side of the equation. So I've got to subtract 1/3 from both sides of the equation. So that gives me x squared minus 5/3 x is equal to negative 1/3. If I subtract 1/3 from this side, the plus 1/3 minus 1/3 will do each other in. And if I subtract 1/3 from 0, that gives me minus 1/3. So that's step 2. Now I'm going to take 1/2 the coefficient of the linear term, square it, and add it to both sides. So 1/2 of 5/3. That's 5/3 times a half, which is 5/6. So 1/2 the coefficient of the linear term is 5/6. 5/6 squared is 5/6 times 5/6, which is 25/36. So I'm going to add 25/36 to both sides of the equation. Again, you take 1/2 the coefficient of the linear term. 1/2 of 5/3, that's 1/2 times 5/3, which is 5/6. Then you square 5/6, so that's 5/6 times 5/6. So that gives you 25/36. So you're going to add that to both sides of the equation. Remember, what you do to one side of the equation, you have to do to the other. Now, this creates what we call a perfect square trinomial. And a perfect square trinomial factors into a binomial squared. To factor a perfect square trinomial, you take the square root of the quadratic term. The square root of x squared is x. You take the square root of the constant term. The square root of 25 is 5. Square root of 36 is 6. So that gives you 5/6. And you use the sign of the linear term, which in this case is minus. So it factors into the quantity x minus 5/6 squared. And that's the whole purpose of creating or completing the square. The whole purpose of completing a square is so that you wind up with what we call a perfect square trinomial. And a perfect square trinomial will always factor into a binomial square. So now what I do is simplify here. So that's x minus 5/6 quantity squared. 1/3. If I write that in terms of 36s, is minus 12/36. In order to add fractions, you have to have a common denominator. The common denominator is 36. 3 goes in 36 12 times, and 12 times the minus 1 is the minus 12. So again, that gives me the quantity x minus 5/6 squared. And now that I have like denominator, simply add the numerators, and that gives me 13/36. So I factored the resulting perfect square into a binomial squared here, and I simplified the right side. Now I'm going to take the square root of the left side. So I'm going to take the square root of this side and plus or minus the square root of this side. Here the square and the square root will do each other in and simply leaves you with what's in parentheses. Now the square root of fraction is the square root of the denominator, the numerator, square root of the numerator divided by the square root of the denominator. So that's plus or minus the square root of 13. Cannot do anything with that. 13 is not a perfect square, and it doesn't contain any perfect square factors. But the square root of 36 is 6. So x minus 5/6 is equal to plus or minus the square root of 13/6. Now solving for x, I need to add 5/6 to both sides. So x is equal to plus or minus the square root of 13/6 plus 5/6. So again, you have two solutions. One solution is x is equal to plus the square root of 13/6 plus 5/6. And the other solution is x is equal to minus the square root of 13/6 plus 5/6. So there are your two solutions. And again, this trinomial is not factorable. So you're going to either have to find the solution by completing the square or using the quadratic formula, which we'll talk about next. Once again, we're looking at the solution to quadratic equations, and quadratic equation is any equation that can be written in the form ax squared plus bx plus c is equal to 0, where a, b, and c are constants. This time, we're going to look at a different method of solving quadratic equations that are not factorable. And again, we can also use this method to solve quadratics that are factorable as well. But if the quadratic is not factorable, then we either have to use completing the square, which we previously discussed, or we have to use the quadratic formula. And the quadratic formula is this creature here. X is equal to minus b plus or minus the quantity square root of b squared minus 4ac all over 2a, where a is the coefficient of the quadratic term, b is the coefficient of the linear term, and c is the constant term if it's written in the form ax squared plus bx plus c equal to 0. So here I've outlined the rules for solving a quadratic equation by using the quadratic formula. So the first thing we need to note, the equation must be in the form ax squared plus bx equal to c. So I said solve the equation 3x squared minus 5x is equal to negative 1. Now notice this is not in the form ax squared plus bx plus c equal to 0. So I need to transpose the negative 1. So I need to add 1 to both sides of the equation. If I add 1 to both sides of the equation, that gives me 3x squared minus 5x plus 1 is equal to 0. Remember, if anytime you take some quantity and you cross the equals, then its sign changes. So the next step is to identify A, B, and C. So in this case, A is equal to 3, B is equal to minus 5, be careful with those negatives, and C is equal to 1. So all I have to do to find out what X is equal to is to utilize these formulas. This formula, that we just call the quadratic formula. X is equal to the opposite of B plus or minus the square root of the quantity B squared minus 4AC all over 2A. So to find what X is equal to, then I simply substitute these values in the appropriate places for these variables in the quadratic formula. Now be careful here, this is the opposite of B. B is a negative 5. So that's the opposite of negative 5. B is negative 5. Take an opposite of B. That is the opposite of negative 5 plus or minus the square root of B squared. So that's negative 5 squared minus 4 times A. A is 3 times C, which is 1. All over 2 times A, and so that's 2 times 3. So X is equal to 5 plus or minus 5 squared. Negative 5 squared is 25. 4 times 3 times 1 is 12. All over 6. So X is equal to 5 plus or minus the square root of 13 all over 6. Now, if you will notice, this is the same problem that I solved by completing the square. So we have two solutions. Our two solutions here are X is equal to 5 plus the square root of 13 all over 6, or X is equal to 5 minus the square root of 13 all over 6. Quadratic equation is of degree 2, so you have two solutions. This is one solution for X, this is the other solution for X. again, we're still solving quadratic equations, and in this particular case, this quadratic is not factorable. So what we need to do here is to either solve this quadratic by completing the square or by using the quadratic formula. So again, I'm going to use the quadratic formula. So let's review the steps. In order to utilize the quadratic formula, the equation must be written in the form ax squared plus bx plus c is equal to 0. And it is. This is a, this is b, and this is c. So a is equal to 3, b is equal to 8, and c is equal to 7. So I've identified a, b, and c. So now I'm going to substitute those values into the quadratic formula. And again, this is the quadratic formula. X is equal to the opposite of b plus or minus the square root of the quantity b squared minus 4ac all over 2a. So x is equal to b is 8, so that's the opposite of b, which is negative 8, plus or minus the square root of b squared. B is 8, so that's 8 squared, minus 4 times a is 3, times c, which is 7, all over 2 times a, and the a again is 3. So x is equal to minus 8 plus or minus the square root of 8 squared 64. 4 times 3 is 12. And 12 times 7 is 84. All over 6. So x is equal to minus 8 plus or minus the square root of negative 20 all over 6. So x is equal to minus 8 plus or minus the square root of negative 1 times 4 times 5 all over 6. Now remember, we have a negative, the square root of a negative quantity, so that's going to give us an imaginary number. 20 is not a perfect square, but I can break it down into the product of two numbers, which one is a perfect square. 4 is a perfect square. So x is equal to negative 8 plus or minus the square root of negative 1 is I. Remember, we learned that when we were discussing imaginary and complex numbers. And the square root of 4 is 2. So I can extract the square root of 4, which is 2, and I can extract the square root of negative 1, which is I, from this radical. So it gives me plus or minus 2I times the square root of 5. There's not anything I can do with that, all over 6. And I can factor 2 out of each one of these terms here. So that's 2 times the negative 4 plus or minus I times the square root of 5 all over 6. 2 times negative 4 is negative 8. 2 times plus or minus I times the square root of 5 is 2I times the square root of 5. Now I can cancel. 2 will go into 2 once. 2 will go into 6 3 times. Remember, you can only cancel products. This is a product. Remember, when I include something in parentheses, it's treated as if it were one entity. So I have 2 times this creature. So I can cancel the 2's, 2 here upstairs, with a factor of 2 downstairs in the 6. So that gives me x is equal to minus 4 plus or minus I times the square root of 5 all over 3. So again, I have two solutions. One solution is x is equal to minus 4 plus I times the square root of 5 all over 3. And the other solution is x is equal to minus 4 minus I times the square root of 5 all over 3. Again, this is quadratic, so there are two solutions. From some of the previous examples where we were solving quadratic equations, we had x squared minus 5x plus 6 equal to 0. We found out it has a solution of x equal to 2 or x equal to 3. In the quadratic equation 3x squared minus 5x plus 1 equals 0, we found that x was equal to 5 plus or minus the square root of 13 all over 6. And in the quadratic equation 3x squared plus 8x plus 7, we found that x is equal to negative 4 plus or minus I times the square root of 5 all over 3. So in the first example, both of these solutions were real, they were rational. In the second example, both solutions were real, but they were irrational. And in the third example, both solutions were unreal, which means that they were imaginary. And one way you can determine if the roots are going to be real and rational, or real and irrational, or unreal or imaginary, is to look at the part of the quadratic equation that is under the radical, b squared minus 4ac. b squared minus 4ac is called the discriminant, and if b squared minus 4ac is a perfect square, something other than 0, the roots are rational but unequal. If b squared minus 4ac, if that quantity is equal to 0, then roots are rational and equal. If b squared minus 4ac is greater than 0 but not a perfect square, then the roots will be irrational and unequal. And if b squared minus 4ac, that quantity is less than 0, then you're taking the square root of a negative number, which means that they're going to be imaginary. So if we look at the quadratic formula, which is in the form ax squared plus bx plus c is equal to 0, and you examine the discriminant, which is b squared minus 4ac, that will basically tell you what type of solution that you have. So in this particular case, we have b, which is minus 5, squared minus 4 times a, which is 1, times c, which is 6. So that gives me 25 minus 24, which is equal to 1. So look at your discriminant here. 1 is a perfect square because the square root of 1 is 1, but it's not equal to 0. So the first condition here is met. b squared minus 4ac is a perfect square, and it's not equal to 0. So that tells you that roots will be rational and unequal. They are rational. 2 is a rational number. 3 is a rational number. Remember, a rational number is any number that can be expressed as a quotient of two integers. And 2 can be expressed as a quotient of two integers, 2 over 1, 4 over 2, etc. Now let's look at the second example. We have b squared minus 4ac. A is 3, b is minus 5, and c is 1. So if we substitute those values into the formula, that will be minus 5 quantity squared minus 4 times a, which is 3, times 1. So here I have 25 minus 12, which is equal to 13. Now 13 is not a perfect square. So b squared minus 4ac is greater than 0, which means it's positive, but it's not a perfect square. So the roots are going to be irrational and unequal. Square root of 13 is an irrational number. So again, that tells us basically what type of solutions that we're going to have. And here, from solving this previously, these were our two solutions, and these two numbers are irrational. The last example, a is 3, b is 8, and c is 7. So if I look at the discriminant, b squared minus 4ac, b is 8, so that's 8 squared, minus 4 times a, which is 3, times c. So that's 64 minus 84, which is negative 20. So here the discriminant is negative. So in essence, what you're doing is you're taking the square root. When you substitute negative 20 in for b squared minus 4ac in the quadratic formula, you're taking the square root of a negative number. So if b squared minus 4ac is less than 0, which means that it's negative, the roots are imaginary. And we see here that the roots are imaginary. So we can determine to a certain extent what our solution is going to look like by examining the discriminant, which is b squared minus 4ac. And again, if b squared minus 4ac is a perfect square, when you take the square root of the perfect square, you get a rational number. So your roots are going to be rational and unequal. If b squared minus 4ac is equal to 0, then this part of the quadratic formula is going to go away. So your roots are going to be rational and equal. If b squared minus 4ac is greater than 0, but it's not a perfect square, then you're going to wind up with an irrational number. If b squared minus 4ac is less than 0, then you're going to be taking the square root of a negative number, which means that your roots will be imaginary.